Welcome, CalcBC. This is lesson 1.5, differentiation, tangent lines, and rate of change. Let's begin. So, this is just going over your derivative rules here. We've learned this before, but power rules right here, constant. Let's go through this. So again, if you have a power, when you derive it, what you do is you take the number up here, put it on the outside, and then subtract 1. So for example, derivative of the function x to the 5th, you take that 5 out, it's going to be 5 on the outside, x to the 4th power. Subtract 1 from that. A derivative of any constant, so it's going to be 0, so the derivative of 5 would be 0. A scalar multiple, well, that means like if you have a number on the outside, you're trying to derive the function times something, just derive that function part and keep that number on the outside. So if I wanted to say the derivative of 4x to the 5th, that's going to be 4 times 5x to the 4th. You derive just the x to the 5th, which is going to be 20x to the 4th. Just leave it in the outside. The sum rule means if you're differentiating two different functions or even different terms, you differentiate each one separately. And let's do some examples of this really quick. So example number 1, power rule, the 4 comes to the outside, so 4, and then subtract 1 from that x, so 4x cubed. Number 2, we can still do this with rational exponents here. So you're going to subtract, you're going to have this come to the outside, so negative 2/3, and it's going to be times x, subtracting 1 from this, so it's like subtracting 3/3 is going to be negative 5/3, and then that plus 3 goes to 0. So this is just my derivative. For number 3 right here, ignore this. So differentiate each separately. So the 5 just goes to 0. That doesn't matter. Now this is kind of weird to differentiate. What I sometimes, this is about rewriting this. So I'm going to rewrite this as 5 minus 1/2. I'm going to bring that t to the cubed up to the top using my power of exponents and write that as t to the negative 3 power. So again, the derivative of 5 is going to be 0. And so I'm going to pull this negative 3 out. So it'll be negative 1/2 times negative 3 times t to the negative 4 power. Negative times negative is positive 3/2 times t to the negative 4 power. If I wanted to rewrite this, I can write that as 3 over 2 t to the 4th power. Either way is fine, but you should be able to do that. Now the last one, so what I might want to do first is I might want to distribute that cube to both the 2 and the x. So I can rewrite that as 5 over 2 cubed times x cubed, which is going to be 8x cubed. And maybe you want to rewrite that again as 5 over 8 with x and negative 3 on top. And now we're going to derive that, so my f prime of x is going to be 5/8 times negative 3 times x to the negative 4th. So negative 15/8 x to the negative 4th, which is equivalent to negative 15 over 8x to the 4th. Either way works. All right. So higher order derivatives, that means you just derive it multiple times. So you can keep deriving forever. And just some notation. So if I have my y prime notation, y double prime, triple prime, if I go more than triple, I might say a 4. I might also do y to the IV, like Roman numerals. You might see that. Same thing if you have function notation. This is the stuff people forget sometimes. They don't write this too much, but if you have the dy dx, d squared y over dx squared. So just remember what those notations look like. If you see this, that means do the double derivative. All right. So skipping these examples for class. Okay, equation of a tangent line. So sometimes we need to find the equation of a tangent line. The key to find a tangent line, so you need to find a line, let's say in point slope form, y minus y1 equals m times x minus x1. So what you need is you need your slope, and your slope is just a derivative at that point. And then you need some point, x1, y1. So you have the slope, which you find the derivative, and then of whatever point. All right. So now this other thing, if you want to find a line perpendicular, sometimes we call this the normal line or the perpendicular line. This might pop up, and it's just the opposite reciprocal. So if we ever try to find a normal line to a point, or we say perpendicular, opposite reciprocal, it's not going to appear too much. So let's do example 1. Equation of a line tangent to the graph at this point. So what I'm going to have to do is I have to find my slope first, which means I have to find the first derivative. F prime of x, using my power rules, 4x to the 5th becomes 20x to the 4th minus 6x. And so I want to find f prime. So this is my point. 1, 6. My x is 1. My y is 6. I'm going to find f prime of 1. So that's going to be 20 times 1 to the 4th minus 6 times 1, which is 20 minus 6, which is 14. So my slope, m, equals 14. I have a point. So I can write y minus 6 equals 14 times x minus 1. Point slope form is fine. You don't need slope intercept. I'll save the other one. Non-differentiability. So when can you not derive on a function? So here's 5 cases where you can't. Sharp turns. So this is usually happens in absolute value functions. If you have a sharp turn, you can't differentiate at that point. So all these cases, you cannot differentiate at x equals 1. Notice I could differentiate here. Basically, the question is, can you find the slope at that point? You can't when there's a hole at 1, because I know you can say, hey, it's probably like the limit. But no, if it doesn't exist, there's no slope at that point, no derivative, not differentiable. Same thing with jumps, asymptotes, and vertical tangents. So these are these weird cases, like at that point, it's technically a vertical tangent, so it's not differentiable at this particular point. It's kind of like a sideways cubic. So 5 characteristics to find. So these you can't derive because it's not continuous. So boom, boom, and boom, it's because it's not continuous. You need to be continuous, differentiate. And then these are just because sharp turns or your derivative is a vertical tangent line. All right. Note that a function is not continuous. It is not differentiable, like the first 3. And then that's, okay, this is what I just said. It may be continuous, but not differentiable in these 2 cases. Good examples here. So let's save this for class. Yeah, let's do that. I'll do the first one. So this is absolute value of x. So where is it not differentiable? Well, this looks like a big old V doing this. Find the x values where it's not differentiable. That happens if x equals 0. Why? Sharp turn. And let's do the rest later. All right. Is that it? Oh, rate of change. Keep going. So rate of change here. So rate of change, very similar to derivative or slope. But it basically, the rate of change is the slope. It's another meaning for slope. Okay, so slope, not slop. We have, so it's a different, there's 2 ways to find the slope. Sometimes we might want to talk about the average rate of change. When I want to find the average of a rate of change, it's basically just finding the slope between 2 points. It's like the average at the start and average at the slope at the start and the slope at the end. The rate of change is just the slope between 2 points. So doing what you did before. Sometimes I try to find instantaneous rate of change. It means I want to find the derivative at a single point. So it'll be like at time equals 3 seconds or something like that. So that might happen. Let's do this. Example right here, average rate of change. So again, if I'm finding average rate of change, I'm not deriving. I'm just finding the slope between these 2 points. So I have 2 points. I'm going to write this as an ordered pair. It's 10 something and 30 something. I got to figure out the something, so I'm going to plug in. F of 10 is going to be 10 cubed plus 2 times 10, which is 100 plus 20, so 120. And f of 30 is going to be 30 cubed plus 2 times 30, which is 60. That's going to be 960. Awesome. Big numbers. So it's just the average rate of change. We can just say slope, which is, we'll call this the 1s and this is the 2s. So it's going to be 960 minus 120 over 30 minus 10, which is going to be 860, 840 over 20. If you reduce the zeros, it's going to actually reduce to 42 is your slope. All right, well, instantaneous rate of change, let's just do this. You got to find the derivative first. So f prime of x, which is going to be 3x squared plus 2. And now we're going to find it when x equals 10, so I have to find x prime of 10, which is going to be 3 times 10 squared plus 2, which is 100, 300, 302. Awesome. Did it. We're done. Yes.